Welcome to today's episode of Tech Talks, where we dive into the fascinating intersection of gaming and technology. I'm your host, and today we're exploring an exciting project that attempts to bring artificial intelligence into the classic Pokemon Fire Red game. Picture this: AI navigating through the Kanto region, battling trainers and catching Pokemon, all autonomously. Intrigued? Let's get started. So, the project we're discussing involves creating a bot capable of playing Pokemon Fire Red using an emulator called RetroArch. Now, at first glance, this may sound like just another programming endeavor, but as the creator puts it, building this bot felt more like producing television than traditional coding. Can you imagine? It's like directing a live-action series, but instead, you're working with code. Imagine the challenges they faced. The core technical hurdle was sending inputs programmatically to the emulator. RetroArch has this UDP-based input system, which is like a fancy network communication method. But our creator encountered reliability issues, which is a major roadblock. To circumvent this, they had to get creative and used OSA script, essentially a way to send keyboard events to the emulator. But here's the kicker. This approach required the game to be in focus, monopolizing the entire computer. It's a bit like trying to play a video game on mute while you simultaneously manage a live stream. Now, what's particularly fascinating is how they managed game memory. They treated the bot's experiences like a diary, recording actions and learning from failures. If the AI tried to move somewhere but hit an obstacle, guess what? It remembered that mistake and avoided doing it again. That's some serious learning at play. When it came to navigation, the project really delved into pathfinding algorithms. They extracted map data right from the emulator's memory. With this information, the AI could chart a course through the game world, making decisions based on valid movement options. I mean, can you imagine an AI thinking, do I go south or east? Much like we do when choosing directions in our everyday life. And let's not forget about game text parsing. The AI needed to understand the game's dialogues and interactions. Instead of reading the memory directly, which is a bit tricky, they opted to take screenshots and then used optical character recognition, OCR, to decode the in-game text. This technique is crucial. Without it, the AI would be utterly lost, unable to interact with characters or follow the storyline. Now, integrating a language model like OpenAI's GPT-4o was a game changer. They leveraged the model to process all the information gathered, helping the AI make decisions based on its surroundings, past actions, and even possible next steps. They designed prompts to guide the AI, avoiding repetitive actions. It's like training a puppy. You want to encourage good behavior while discouraging those "whoops, I did it again" moments. However, there were some rough edges too. The battle handling aspect was rather simplistic. It mostly just pressed A, repeatedly. If a battle lasted too long, random inputs would kick in to break free. There's definitely room for improvement there. A real-life trainer would probably be a bit more strategic. As for interaction with NPCs, the AI assessed whether conversations were ongoing, essentially checking if the dialogue had moved forward and responding accordingly. It's like having a friend who keeps on talking as long as you're engaged and only moves on when you've nothing more to say. But it wasn't all smooth sailing. The biggest challenge was that pesky input limitation from the emulator. So frustrating. The developer paused progress, reflecting on the technical hurdles faced. They likened the project to a mix of challenges and enjoyment, which is a sentiment many tech enthusiasts can relate to. Before we wrap up, it's worth noting that advancements in language models like